Let's talk about a thing or two regarding star delta transformation. The first one we are going to deal with is star to delta conversion. Here, if suppose you are given a star connection with resistances R1, R2 and R3 and you want the equivalent delta connection with resistances RA, RB and RC. Okay, you can easily apply these formulae for the calculation of RA, RB and RC. An important thing that you have noticed is that the numerator is same, okay, which is R1, R2 plus R2, R3 plus R3, R1. Okay, this term is common in all, okay, in RA, RB and RC. The numerator is same, but the denominator is different. How to remember the denominator? Okay, the trick is, if you want to calculate this resistance, you take this resistance in the denominator. If you want to calculate this resistance, you take this resistance. If you want to calculate this resistance, you take this resistance into denominator. Okay, as you can see, for the calculation of RA, R1 was in denominator. For the calculation of RB, R2 was in denominator. For the calculation of RC, R3 was in denominator. Okay, this is a trick to remember. The numerator is same and the denominator is hence remembered by this trick. Now we shall be dealing with delta to star conversion. Okay, suppose if you are given a delta connection with resistances RA, RB and RC and you want the equivalent star connection with R1, R2 and R3. Okay, you can easily calculate R1, R2 and R3 using these formulae. An important thing that you have noticed that the denominator is same, okay, which is RA plus RB plus RC. This is the common numerator for all the calculations regarding R1, R2 and R3. The denominator is same, but the numerator is not. How to remember the numerator? For the calculation of R1, you do not take RA, okay, you take the other two. Okay, for the calculation of R2, you don't take RB, you take the other two. For the calculation of R3, you don't take RC, you take the other two. Okay, so for the calculation of R1, you see that RA was not taken, RB and RC were taken. For the calculation of R2, RB was not taken, RA and RC were taken. Okay, for the calculation of R3, RC was not taken, RA and RB were taken. So this is an important trick to be remembered. And an important thing is, if we have extra resistances connected to the terminals, okay, here we are taking an example. Suppose alpha ohm is connected to RA and RB and beta is connected to RC and RB at this point and gamma is connected at this point. Okay, so after converting this delta into its equivalent star, what would be the position of these resistances alpha, beta and gamma? Okay, these are attached as per the formulae. Okay, the funda that we use to remember the numerator, the same funda would be applied. Okay, so if it is connected to RA and RB, okay, as you know that RA and RB was in numerator regarding R3. Okay, so this alpha would be connected to R3. Okay, now we take the beta. Okay, beta is connected to RC and RB. As you can see, RC and RB are over here. Okay, so this will be connected to R1. Okay, this beta will be connected to R1. Now you can see gamma is connected to RA and RC. Okay, RA and RC are over here, so this will be connected to R2. Your gamma would be connected to R2 and the circuit would be, the positions of the other resistance would be such. As you can see that alpha is connected to RA and RB. Here you can see RA and RB is connected to R3. Okay, so this alpha would be connected to R3. Okay, now we are dealing with beta, which is connected to RB and RC. Here you can see RB and RC in R1, so beta would be connected to R1. Okay, now we are having gamma, which is connected to RA and RC. RA and RC is in with R2. Okay, so we will be attaching this gamma with R2. Okay, so this is an important thing to be kept in mind because this question has been asked in ESC prelims in the year 2011 and question regarding such cases have been asked in conventional papers as well, in ESC mains as well as IAS mains. Okay, so you have to keep this funda in mind, and this is all for star delta transformation.